Hello everyone, my name is Ajay Medhi. In this presentation, I am going to discuss about study of expert system for integrated cupping and punching operation. Abstract. Combination dies are used for production of sheet metal parts having two or more operations in a single station. There are many sheet metal combination parts applications facing the die designer. This kind of die design considers one of the most complicated design in the tool room. There are many classification of sheet metal parts can be arranged under the combination die. One of them is the cupping and punching dies. In this presentation, a classification of cupping and punching die types into groups and computer aided design for parametric design of combination dies are discussed. The CAD system is developed using knowledge based system technique of artificial intelligence. The system is capable to design cupping and punching combination dies for production of sheet metal parts. The system is coded in Visual Basic application of Excel and integrated with SolidWorks software. For each cupping and punching part shape, there is an appropriate die design shape. The system designs the part shape parametrically, storing the part dimension into database and then design the related appropriate combination die design. The program provided with a knowledge based rule to categorize the limits for the system metal parts with the appropriate die design shape. The low cost of the proposed system will help die designers of small and medium scale sheet metal industries for design of combination dies for similar type of products. The proposed system is capable to reduce design time and efforts of die designers for design of combination dies. Introduction. The term compound and combination have frequently been interchangeable, used to define any one station type, the elements of which are designed around a common center line and in which two or more operations are completed during a single press stroke. This kind of dies are classified into compound and combination dies, in which compound dies is press tools in which only cutting operations are done, usually blanking and piercing dies, and combination die is press tools in which a cutting operations is combined with a shaping or deformed operations, etc. The range of these types of combination die is much greater than in the case of compound dies. Two or more operations such as forming, drawing, extruding and embossing may be combined with each other or with the various cutting operations such as blanking, piercing, trimming, broaching and cutting off. Most of the success of such dies depends on the provinces for stripping and ejecting finished parts. Die types classification in combination die. Classification of sheet metal combination parts. Sheet metal combination products is features by two operations, one of them in 2D such as shearing operations and the other 3D such as bending, drawing or forming. Under this title, many sheet metal products can be classified. Narji classified the products under this category into blanking and coining, bending and punching, blanking and bending, punching and cupping, drawing, blanking and drawing. The parts under the title of cupping and punching can be divided into cupping with punching in the bottom of the cup, cupping with punching in sides and cupping with punching in the flange. Figure 1 shows some sheet metal parts under this classification. It must be noted that the punching hole in which each case of the classification is not fixed. As example, we can consider one hole in the center of the cup bottom, but it could be also 2 holes or 4 holes or more. In the same case, we can consider one hole in the side as a blind case, but it may be also 2 holes or 4 or more. In the same way, we consider 1 or 2 or 4 holes in the flange. Figure 1 shows some sheet metal parts under this classification. It must be noted that punching holes in each case of the classification is not fixed. As example, we can consider one hole in the center of the cup bottom, but it could be also 2 holes or 4 holes or more. In the same case, we can consider one hole in the side as blind case, but it may be also 2 holes or 4 or more. In the same way, we can consider 1 or 2 or 4 holes in the flange. In this figure, it's showing classifications of cupping and punching operations. Classification of combination die types. According to the classification discussed for the cupping and punching sheet metal products, there is an associate cupping and punching die types designs need to produce those parts. Those die type designs collected from handbooks, research papers, and internet websites. As an example, for produce a blank cup with no pens inside. The program description. For each suggested cupping sheet metal part feature, a parametric relations and equations are made to connect between the part and die dimensions. The relation will start first from the cup part to the strategic parts of the die design and finally to all the other die components. The proposed program package is prepared using Visual Basic, Excel, and SolidWorks. The Visual Basic work is as user interface and controller between the other programs in the package. The program includes formulas of design calculations and parametric equations prepared to deal with the design steps of the program, such as making thickness, drawing shape. Each equation has a set of predefined variables. In the case of determining the plane, the variables are, in the case of parallel plane, the variables are at the beginning. A complete CAD model of both the sheet metal cup as product and the combination die are prepared, including all the die components. For the cup product, the part dimension could be controlled using a tailor-made program. As the important cases include the relation between the cupping operations and the punching operations, could be classified as cup with hole or holes in the bottom, cup with hole or holes in its wall. Finally, cup with hole. The proposed program main menu design according to this philosophy. Figure 10 shows the main menu, including a classification of the three main cases could be available in the relation between punching and cupping. Relations are made between the part dimension and the strategic die dimension. Figure 13 shows a 2D die design drawing made to study the relation of dimension between the part and die. All the parametric relations and calculations equations are inserted inside a VBasic code variables. These variables are connected with the user interface of the proposed program. The user needed to enter only the required dimension of the sheet metal cup. These dimensions are translated inside the program to the parametric design of the punch and die dimension, and then to the complete combination die design. Conclusion. The CAD system is developed using knowledge-based system technique of artificial intelligence. The system is capable to design two sheet metal operation at a time. The system is coded in Visual Basic application of Excel and interfaced with SolidWorks software. The parametric nature of the proposed system helps to save design calculation time. The proposed system is valid for various real-time sheet metal and parts. In this diagram, these diagrams are designed in AutoCAD software. It is used to design and drafting many other SolidWorks. Like we can design a part using AutoCAD. It is very necessary and important for students. Conclusion. The CAD system is developed using knowledge-based system technique of artificial intelligence. The system is capable to design two sheet metal operations at a time. The system is coded in Visual Basic application of Excel and integrated with SolidWorks software. The parametric nature of the proposed system helps to save design calculation time. The proposed system is validated for various real-time sheet metal parts. Thanks for watching. Thanks for watching.